Welcome to the deep dive. Today, we're tackling a really surprising paleontological puzzle. It's about a dinosaur fossil found in Africa that, well, it really shakes up how we thought these animals were spread across the planet.
It definitely does.
And we know you want to get straight to the interesting stuff, so our mission today is pretty clear. How did a dinosaur type, one never seen before in Africa, actually end up there? We'll be digging into the science papers and articles about it.
Yeah, let's jump in.
Okay, so let's unpack this. What are we talking about?
Right, so the star of the show is Ajnabia odysseus.
Mm.
And, the name itself kind of gives the game away. Ajnabia. It means stranger or foreigner in Arabic,
Ah, okay.
which is just perfect, really, given how unexpected it was finding it where they did.
It makes sense, and the timing here is key too, right? Late Maastrichtian.
Exactly. We're talking the very, very end of the Cretaceous period, like right before the big asteroid impact.
Wow, close call.
And the specific spot was the phosphate mines at Sidi Chene over in Morocco.
So, late Cretaceous Morocco. And suddenly, you find a dinosaur that looks like it belongs somewhere else entirely, like Europe.
Precisely. Ajnabia is a lambeosaurine hadrosaur, duck-billed dinosaur.
Uh-huh.
And even more specifically, it fits into the Orenisaurini tribe. And that group, well, its known members like Orenissaurus, they're all from Europe.
Okay, so that's the connection, European relatives.
Yeah. And if you think about dinosaur biogeography, like how they were spread out, finding a European-style hadrosaur in late Cretaceous Africa, that's a real head-scratcher.
Because Africa was basically an island then, wasn't it? That's what the research points to. Big stretches of water all around, cut off from the northern continent.
Absolutely. Totally isolated.
No, the thinking was always that hadrosaurs, which you find lots of elsewhere, just couldn't have made it to Africa. It's like, I don't know, finding a polar bear wandering around Egypt or something. It just doesn't fit the map we had.
Exactly that. The scientific picture we had painted Africa's dinosaur fauna back then as, well, unique, shaped by its old connections to the southern continent's Gondwana.
Right.
So finding a hadrosaur, a group we strongly link with Laurasia, the northern supercontinent, it really throws a wrench in the works.
Okay, let's picture Ajnabia itself. What did it actually look like? The study suggests it wasn't huge.
No, it was actually quite small. That's another really interesting part. The estimates put it around maybe 3.5 meters long, about 11 feet, which is pretty similar to another related dinosaur from the same place and time, Mincaria.
Mm-hmm.
And the holotype, the main fossil they used to describe it, which is just an upper jawbone, by the way.
Just the jaw.
Oh,
Okay.
yeah, just the maxilla. But based on that, if it was a fully grown adult, Ajnabia might actually be one of the smallest hadrosaurs we know of.
Really? Smallest?
Potentially, yeah. Which, it makes you wonder about island dwarfism, that phenomenon where animals isolated on islands sometimes shrink over time. But honestly, we'd need more fossils to be sure about that.
Right, makes sense. So this little stranger was living in a very different setting compared to, say, the big hadrosaurs in North America. What was that Moroccan ecosystem like?
Oh, it was fascinating. The rocks it was found in, these phosphate deposits, tell us it was a nearshore marine environment.
So, coastal.
Yeah, think coastal waters, probably teeming with sharks, lots of fish, and those big marine reptiles, the mosasaurs.
Sounds dangerous.
Definitely. Dinosaur fossils are actually pretty rare in those deposits, which isn't surprising given the marine setting. But we know Ajnabia wasn't alone on land.
Right. You mentioned other dinosaurs were found there too, like that big predator, Tyrannosaurus?
Tyrannosaurus barbaricus, yeah.
Yeah.
A big abelisaur, that would have been the top predator around there for sure.
Okay.
And the research also mentioned there might have been other smaller abelisaurids too, plus an unnamed titanosaur, one of those long-necked sauropods.
So a mix of things.
A real mix. And what's really interesting now, especially with finds like Mincaria too, is that it looks like these duck-billed dinosaurs, these lambeosaurines, weren't just a fluke. They seem to have been, maybe even a fairly diverse and common part of that coastal ecosystem.
Huh. For how long?
Well, for about the last million years or so before the big extinction event.
Okay, so we've got this picture. A small European-style hadrosaur living by the coast in Morocco, surrounded by sharks, mosasaurs, and some very different-looking Gondwanan dinosaurs like abelisaurs and titanosaurs, all on this isolated continent.
Pretty much sums it up.
Which brings us back to the massive question, how on earth did it get there? The science seems to be leaning towards something pretty wild. Crossing the ocean.
That's where it gets really fascinating, yeah. You look at the maps of how the continents and oceans were arranged back then, late Cretaceous. Africa and Europe were separated by some serious water.
Right.
So the most logical explanation, strange as it sounds, is that Ajnabia's ancestors somehow crossed that water from Europe.
Wow.
Now, the idea of dinosaurs crossing oceans, oceanic dispersal, it's not totally brand new. It's been talked about for some European hadrosaurs
Oh,
too.
okay.
But the difference there is, for Europe, you could maybe argue for temporary land bridges popping up sometimes. With Africa, that connection just doesn't seem to have been there. The water barrier was much more significant and permanent.
And the researchers looked at other ideas too, didn't they? Like maybe the fossil just floated over?
They did, yeah. They consider if the Ajnabia jawbone itself could have washed over from Europe somehow, maybe after the animal died.
Seems unlikely.
Highly unlikely, they concluded. Based on the fossil's condition, the taphonomy, how it was preserved, and the fact that, well, it doesn't perfectly match any known European dinosaur.
Okay.
Plus, if there had been a land bridge, like a walkway, you'd expect to see a whole bunch of other European animals showing up in African fossils from that time, and vice versa.
Yeah.
And we just don't see that broad exchange.
Right. It's just this one specific group, the hadrosaurs.
Primarily, yes. Which points away from an easy land connection.
So no walking, not a drifting fossil. It must mean living dinosaurs somehow managed to cross the water. How? What are the possible ways?
Well, the papers discuss a few options. Swimming is one possibility.
A dinosaur swimming across an ocean.
A long swim across open ocean would be incredibly tough, especially for a land animal not adapted for it. Maybe possible, but very difficult. Drifting on currents is another idea.
Just floating along.
Maybe, but probably the most talked about mechanism, especially maybe for smaller, younger animals, is rafting.
Rafting. Like on a log.
Exactly. Getting washed out to sea on big floating mats of vegetation or large logs, things like that, torn loose during storms, perhaps.
Ah.
It's harder to imagine a full-sized adult doing that, but maybe juveniles could have been accidentally transported that way, like little dinosaur stowaways on a natural raft.
That's an incredible image. Dinosaurs as accidental sailors. And this whole discovery, it fits into a wider picture of Africa's ancient life, doesn't it? The research mentions North Africa's fauna had stronger links to the southern continents, Gondwana, than to Europe.
That's a crucial point, yeah. If you look at Laurasia, the northern continents, you had dinosaurs like T-Rex relatives, lots of different ornithischians.
Right.
But Gondwana, the southern continents, that was the land of titanosaurs and abelisaurs. And as we said, those are the types of dinosaurs we find in Morocco, alongside Ajnabia.
So it mostly looked like a Gondwanan outpost, but with this weird European visitor?
Kinda, yeah. But even within that Gondwana connection, North Africa seems to have had its own unique flavor. Some endemism species evolving in isolation.
Like you see on islands today.
Exactly. Like other bits of the old Gondwana that had broken apart.
And there are examples of that local uniqueness mentioned.
Yep. They mention a small abelisaur from another site, Sidi Dowie, and also that Chinanosaurus itself might represent a distinct lineage, separate from other known abelisaurs.
Okay.
And it's also interesting what's missing. While North Africa had titanosaurs and abelisaurs like South America did, it seemed to lack other groups found there, like armored ankylosaurs or certain types of feathered theropods.
So different parts of Gondwana were already going their own evolutionary ways.
Exactly. That fragmentation was well underway, and some studies suggest there might have even been a sea cutting across the Sahara back then, the Trans-Saharan Seaway.
Oh, wow.
And maybe Morocco itself was effectively an island or peninsula,
Ah.
all of which would have increased the isolation.
Making Ajnabia's arrival even more statistically improbable, you might say.
Absolutely. Which is why it's such a significant find.
So pulling it all together, Ajnabia isn't just some curious fossil. It's solid evidence, maybe the best we have for dinosaurs, that they could cross major ocean barriers. It forces us to rethink their capabilities.
Totally. The researchers really stress this. Ajnabia is the first definitive hadrosaur from Africa. Period.
Right. Unequivocal.
Its existence is really important support for this whole idea of oceanic dispersal being a real factor in how dinosaurs got around, especially maybe between the islands that made up Europe back then too. It challenges those old assumptions about how limited they were by water.
Okay, so wrapping up our deep dive here. The discovery of Ajnabia, this stranger, in late Cretaceous Morocco, tells a pretty amazing story. It suggests that somehow, against the odds, these duck-billed dinosaurs crossed a significant ocean barrier from Europe to Africa.
Yeah, most likely via some form of oceanic dispersal, swimming, drifting, or maybe rafting on vegetation.
It really unlocks a new perspective on dinosaur abilities and how ancient ecosystems might have been connected in surprising ways.
It definitely does. And maybe it leaves us, and you listening, with a final thought to chew on.
Go on.
Well, if a hadrosaur, a plant-eating land animal, could make such an incredible journey, what other unexpected dinosaur travelers might still be hidden in the rocks, waiting to be found in places we never thought to look.
Hmm. And what could those finds tell us about how life really spread across our planet millions of years ago?
That's a great question to end on.